Okay, so the goal for ChiSquare test for independence is we have two variables right here. The variables that we have are political party and your opinion on tax reform. So what we're trying to investigate right now is we're trying to see if these two variables are independent for each other, or we're assuming they're independent. What does that mean? We're saying your political party has no bearing on your idea on what if there should be tax reform or not. Then we're trying to prove that there is a relationship. And so how we go about this is we have our observations. So right here, this is what happened. These are all our observed values. And in order to see if they are independent of each other, we have to see, well, what would our predicted, or what is our expected values, excuse me. What should have happened? And in order to do that, we need to find the expected counts. So that's your first step. For goodness of fit, we had two formulas for expected counts. We had n times p, it's over here on the board, where n was your total sample and p was the percentage that was given. And you had to change that to a decimal. When it was evenly distributed, we took the sample size and we divided by the number of categories. For ChiSquare tests of independence and homogeneity, the expected counts will have the same formula every single time. It is equal to your row total times your column total divided by your table total. What I did for you right here is I just rewrote the table and I left the cells that mattered blank. The totals will stay the same every single time because we interviewed 500 people and 285 of them were Democrats and 215 of them were Republicans. Okay, so how do I find the expected counts? Make sure you have the table written down that I have here. I know this part is tedious again. What? Oh, this table right here, the one with the blanks. Okay, so that's what you're writing down. What's the goal of this step again? Is we're trying to figure out what should have happened. What do we expect to happen? The first table is what we observed to happen. Okay, those were our observed values. And in order to see if these two variables are independent or not, we need to find our chi-squared value. So we need to find the difference of our observed minus our expected. Like I said, it's tedious. This is a tedious step, but now once you have it down, you'll have it down for homogeneity as well. So we won't have to take as long talking about it on Wednesday. No, it should be much faster. Yeah, question? You do need to draw the table again. There's 6 steps. Step 1 and step 3 are the most time consuming. All right, are we ready? What I want to do right now is I want to figure out the expected value for Democrats who favor tax reform. So I want to figure out this cell. I know the observed count is 138. To figure out the expected count, I need to take the row total. So the row total is 285 times the column total for that cell, 202, divided by our table total, which I circled right here, 500. So do that now with your calculator and make sure you're clear on how you type that in. You want to take 285 times 202, hit enter, and then divide by 500. And I got 115.14. We're going to do it again for Democrats who are indifferent. So we know right now the observed value for Democrats who are indifferent about tax reform is 83. What's the expected value though? What should have happened? So again, I take the row total, 285, times the column total, 150. I hit enter, so I don't type it in my calculator wrong. And then I divide by 500. And I get 85.5. Let's do it one more time together, and then I'm going to have you find the bottom row, just to practice to make sure you have it down. So now I know the observed value for Democrats who are opposed to the tax reform bill is 64. To figure out the expected, I need to take, which would be right here, my row total, 285, times my column total, 148. Divided by my table total, 500, and I get 84.36. I want you guys to practice right now with the Republicans, okay, with this row. So you need to figure out the expected value for Republicans who are in favor of the tax bill, who are indifferent, and who are opposed. I'm going to walk around right now, and I'll check in with you and see how you're doing. If you have questions, let me know at this time. All right, so we have it all down, and just as a reminder, what is these expected counts? These expected counts are what should happen if the political party is independent of our opinion on tax reform. So if they are truly independent, this is the observed, or this is the expected counts and what should happen. And you can note that they are different than our observed values. So our observed value 138 versus 115, 64 versus 86. The question is, are they so different that we have evidence that they're not independent? So to get there, we have to go to step 2. And step 2 is our hypotheses. Okay. The null and alternative hypotheses, I think, are easier to write than your goodness of fit ones. And I'll type them for you so you can read it a little bit better. Your null hypothesis always needs the word, or the words, is independent in it. We assume that there is no association between them. How do I phrase it? It's very easy. You just take the two variables, tax reform, political party, and you say they're independent of each other. So, HO, political party, is independent of tax reform opinion. If this is true, we see what the expected counts should be. Okay, we found that. We know that there's a difference. So already we have evidence for HA. Okay, because the expected value up here for if they're independent is different than what we actually observed. So we have evidence right now that they are maybe not independent. And that's our HA. Our HA is always the two variables, and we just say they are not independent. Every single time, just take your two variables, it's an is statement, it's an is not statement. party isn't independent of tax reform opinion. So step 2 isn't too bad. Look that over. Do you guys have any questions? Yeah, question? Yep, so what I mean by independent is in our null hypothesis, when we say political party is independent of tax reform opinion, it doesn't matter what your political party is. That has no influence on how you're going to vote on this tax reform bill, okay? What we're trying to prove is that it actually is not independent, that there's a relationship there. And we can see that there may be a relationship already. And how do we know that? Again, by looking at the observed, right, up here, is different than this grid that we filled out. This grid that we filled out is what we expect to happen if they're independent, if one has no bearing on the other, no influence on the other. Did everyone get step 2 down, the null and alternative? Do you need me to go back to that? Did that answer your question, Joe? Yeah. Okay. All right, I'm going to take a quick picture so I have the values. And I can shrink it down. If it pops up at all. Okay, it's not popping up for me, so let's just move on to step 3. You guys will have to help me out. There it is. Okay, so step 3 is we need to find the chi-squared value. The chi-square value stays the same for everything. It's over on the board, and it's that sigma. Sigma means sum, so it's the sum of the observed counts minus the expected counts divided by, squared, divided by the expected. So let's write it down. Like I said, step 1 and step 3 are going to be the most tedious. When you guys get to college, you'll have technology that will help you with this. So it'll go much faster. Although most professors will make you show your work a little bit, so it won't just be plugging things in and then writing it down. You'll have to show that you actually understand this process, like what's behind it. You won't have to show as much work that I make you show, but a little bit. So it's good that you have a good understanding of it. Okay, so we know our chi-squared value is the sum of our observed minus our expected squared divided by our expected. And we have 6 observations. If you look at your cells, not including the totals, there are 6 things that we observed. So I'm going to just right away write that down. Parentheses, squared, plus, parentheses. I'm going to write down just all the observations first. So the first observation was 138, I believe. Yes? Or question, Lee?
Oh, are we able to use a calculator on this one?
So if you have a graphing calculator, I can show you how to do that, but not at this moment, because I do want, you're going to have to show a lot of this work, but it will make your life a little easier.
Can we do what we did for the last one? That would be
It's a little bit,
the first one?
yes, exactly. So, can I get some help though with the 130, was it 138 your first observation? Okay, what was the next observation? Sarah, can you tell me?
Observation for Democrat and different.
Yep, so just, I'll go down the line.
Oh,
83. Okay. The next observation, what was it? After 83? 64? Okay, what was the next observation? Can someone read it to me? Was it 64 again?
no.
Okay. And the next observation? 67? Yes? 67, okay, and then the last one? 80 what? 84. Can I get someone to read off the expected for me nice and clear? Sarah, can you do it, Sarah T?
115.4.
113.4 was the first one? 114?
115.14.
Thank you. Okay, what was the next one? 85.5. So I'm taking my observed minus my expected divided by my expected. Okay, next one.
84.36.
Okay.
86.86.
Okay.
64.50.
64.05. 64.5. Okay. And
63.64.
in order to make this quick, I'm going to assign one to each of you. Okay. So I'm going to have Sinclair. Can you do the first one? Okay. Megan, can you do the next one? Okay. Sharon, do you have a calculator? No. Keita, do you have one? Can you do the third one? Okay. Janai, do you have a calculator? Can you do this fourth one? Sarah, do you have a calculator? Can you do the fifth one? And then Kendra, do you have a calculator? Can you do the last one? Thank you. So what are people doing right now? They are calculating each term that we have for that observed minus the expected squared divided by the expected. Sinclair, do you have the first one?
Yeah, it's 4.54.
4.54. Megan, do you have the second one?
0.07.
0.07.
Yeah.
Who had the third one? You think you got it wrong, did you say? Okay, so 64 minus 84.36 will be a negative. Then you square it. Not yet. Okay. And then you divide by 84.36. And I got 4.91. So you got it? Okay, great. 4.91. All right, who is next? Janai, were you next? 6.02. Okay, who is next? Sarah? 0.09. Kendra, what did you get? 6.51. Awesome. Now, what do we have to do? We have to add all 6 values up. So if you could do that now, that would be wonderful. Practice it now, guys. You want to make your mistakes in class so when you get to the test, you learn from it and you feel comfortable with it. Has anyone gotten it yet? 22.14. Thank you very much, Joe. Okay, we eventually need to get our p-value. Before we get our p-value, does anyone have any questions about chi-squared before I move on? Okay, in order to get our p-value, the first thing we need is our degrees of freedom. And the degrees of freedom has a formula. It's the number of rows. I'm going to actually, give me a second, because it should be plural. It's the number of rows minus 1 times the number of columns minus 1. People make mistakes on this one all the time, and there's a reason for that. Okay, so get the formula down for your degrees of freedom. That's really imperative.
Is there ever a -2 or -3?
Say it again.
Is there ever a -2 or -3?
There's not a -2 or -3 for our curriculum. When you get to regression tests, there it is -2. Does everyone have the formula written down? Okay, so here's where people make mistakes all the time. The number of rows that we have. I go to my original table. And people say that there are 3 rows. They'll say, oh, 1, 2, 3. And people say that there's 4 columns. But what? The totals do not count. Very good. Make a note to yourself if you are going to forget that. The totals do not count for your rows or your columns. So there's only 2 rows and there's 3 columns. Columns are up and down, rows are across, right? Okay. Again, write a little note to yourself if you're going to forget that. The totals don't count in the rows or the columns. So our degrees of freedom. We're almost done, guys. You're doing a good job. We're going to take 2 minus 1 because there's 2 rows, times 3 minus 1 because there's 3 columns, and 2 minus 1 is 1, times 2. So our degrees of freedom is 2. We have our chi-square value, we have our degrees of freedom, and now it's time to estimate the p-value. You need your chart to estimate the p-value. Does anyone need an extra chart for chi-square? If you've been absent, I do have the goodness of fit notes online as well. Anyone else need the chi-square goodness of fit? I'm sorry, chi-square table for estimating your p-value. Again, when you use graphing technology, you'll be able to get your actual p-value, not just an estimate. So I'm going to go to my 2 degrees of freedom. I'm going to go across the row, and I'm going to see where does 22.14 fall. So practice using the table now if you've forgotten. Get your table out. Some of you guys don't have your tables out. Practice it.
Is it greater than 15.2?
Okay, so what? Okay, so Trenton noticed that 22.14 goes off the chart, right? Which way does it go off the chart? To the right or to the left? Right. To the right. And as we go across the table, our p-values, do they get smaller or bigger? They get smaller. So what's happening is our p-value is smaller than this last p-value, 0.0005, because it went off the chart. So if you were done and you don't know how to read the table, ask during work time or watch the video, because I have like the table on the Smart Notes where we go through it. So we say our p-value is less than 0.0005. That means we have a really, really small p-value. We don't know the exact p-value unless we use graphing technology, okay, like a graphing calculator. But we know that it's super small. And since it's super small, when the p-value is low, we always reject the HO, okay? The p-value is low, we reject the HO. So now we're at the time where we can write our conclusion. And when we write our conclusion, here it is. Because our p-value is less than alpha, we reject the H naught or the HO. We have evidence that the political party is not independent of tax reform. So that means what your political party is influences how you feel about tax reform, for this case at least. Are there questions?